Hello students, welcome to Narayan PU College online classes. So in the last video we have discussed about the Lewis symbols, or we can simply say Lewis dot symbols or electron dot symbols. Lewis texture also can be called. Okay. So in the last class that we have discussed about the Lewis textures of atoms or Lewis symbols for the atoms and ions. And in this class we will discuss about the Lewis representation of simple molecules and ions. Means not single ion here and molecule containing ions. For that one, how to represent the Lewis texture for the molecules and molecule having the means ions. Ion containing positive ion or negative ion containing, but molecules how to write the Lewis representation. Okay, so very important this is. Okay. And to write the Lewis representation for the molecules and ions, we have to follow here some rules. We have 4 rules. Okay. So one by one we will discuss, and while writing the Lewis representation, you have to follow each and every rule while writing. Okay. So what is the first rule? Okay. See here. In this one, the first step, calculate the number of valence electrons of the atoms. Clear? You have to calculate the number of valence electrons of the atoms present in the molecules. That is the first step. Clear? And if the species is anion, if it is anion, suppose I will write here SO4 2 minus. This is molecule. Molecule is having what? It is anion. Molecule is what is here? Anion. So if the species is anion, add the number of electrons equal to the units of negative charge. Clear? So minus 2 means what? It gains 2 electrons, means you have to add the 2 electrons to the total valency of the electrons. Suppose here for just assume for this one SO4 total valence electrons are X. For you, what you have to do? You have to add the 2 electrons. Why? Because in this one the molecule is having negative charge. Negative charge when the molecule, when the atom gets the negative charge, when it attracts the electron, it takes the electron. When it gains the electrons, it acquires the negative charge. When lose the electron, the atom if loses electrons, it acquires the positive charge. Clear? No? So negative charge means gaining of electrons. How many electrons gain here? 2 negative charge means 2 electrons gain, and that 2 electrons should be added. If it is a cation, suppose if it is a cation like NH4 plus if it is there. So total number of valence here, valence electrons are X. Then plus 1 means the molecule it lost 1 electron. Means what you have to do? You have to subtract 1 electron from the total valency electrons. That is the second rule. What my point? So first of all, you have to calculate the valency electrons of the each atom. If the molecule is having the negative charge, means anion means negative charge, add equal number of electrons, how much charge it has. Suppose 2 minus as there, plus 2 you have to add. If cation is there, subtract the number of electrons equal to the units of positive charge. Plus 1 is there, 1 electron you subtract. Plus 2 is there, 2 electrons you subtract, like that. Okay? And the third one. Yeah? Select the central atom. While the molecule is there, first you have to identify which one is the central atom. Central atom means what? To that atom, number of atoms are attached. That atom we will call as a central atom. Clear? No? Generally, central atom is least electronegative atom. We will always, most of the time, clear? Some exceptions are there, but most of the time we will take the least electronegative atom as a central atom. Clear? And draw the skeletal structure. Skeletal structure means suppose they have given SO4. First one, oxygen and sulfur. Which one is more electronegative here? Oxygen is more electronegative than the sulfur because fluorine is the most electronegative element in the periodic table, and the second most electronegative element or atom is oxygen. So that's why oxygen is most electronegative, sulfur is less electronegative. So which one should be the central atom here? Least electronegative atom. Which is the least electronegative atom here? Sulfur. So that's why sulfur should be the least electronegative atom. That should be considered as a central atom. Clear? Next, what are there here? Oxygens. Oxygens are there. You arrange. That is no problem. Here you can arrange like this. Around that central atom, that 4 oxygens should be present. And this we will call as a skeletal structure. Okay, so next you have to arrange the electrons that we will discuss. That is here. And central atom, just find out which is the central atom and draw the skeletal structure. This is important. Hydrogen and fluorine usually occupy the terminal position. These are terminal position. This is the central position. Clear? What does it mean? Hydrogen and fluorine never act as a, they never act as a central atoms. Why? Because fluorine is most electronegative in the periodic table. Most electronegative atom never act as a central atom. And why not? Why hydrogen? Hydrogen is not only most electronegative element. Then why? Because being a small in size, hydrogen is very small in size, so that's why it cannot hold the other atoms. If small molecule is there, means central atom has what it has to do. Central atoms has to hold here how many oxygens here? 4 oxygens. Clear? Means if hydrogen is a central atom means it has to hold the electrons. It should have the capability to hold the electrons. And hydrogen very small, it cannot hold the more than, means it cannot hold the atoms. So that's why, and being a small in size, it never act as a central atom. This is the third step. Clear? What is the fourth step? Clear? In the fourth step, put one shared pair of electrons between the 2 atoms. Between the what it is here? 2 atoms. Pair 1, you have to take the which one here? You have to take the put one shared pair of electrons between the 2 atoms. Means suppose here it is the central atom I have taken. Which one is the central atom here? Sulfur is the central atom. So terminal atoms, these are these are what it is, terminal atoms. Clear? Now what you have to put one shared pair of electrons between the 2 atoms to represent the single bond. Suppose here how many electrons are there? Suppose 15 or 14 electrons are there. So what you have to do first of all, you have to put the pair of electron between the central atom and terminal atom. That is the first thing you have to do. I will explain later, but just this is. And how many total you have calculated total number of electrons here? And in that electrons, and first you have to put the pair of electrons between the 2 atoms to represent 2 electrons, and it made one bond, single bond. Clear? One bond means how many electrons? 2 electrons. One bond is made up of 2 electrons. If 2 electrons are there, and we will represent that 2 electrons by a bond, that is only a single bond. Clear? Now I have used here total, just assume 14 electrons are there, and here I have used how many electrons here? 1, 2, 3, 4, 8 electrons. Remaining are there here. 8 electrons means how many here? 6 electrons are there, and pairs you have to consider. 6 electrons means 3 pairs, and that is use the remaining pair of electrons for multiple bonding or to show them as a lone pair. To show them as a lone pair, and you can put in central atom, and that remaining electrons you have to arrange for the multiple bond, or you can keep those as a lone pair. And remember one point here, very important, keeping in mind that octet of each atom should be completed. So these are the 4 rules, and no problem if I take 1 or 2 examples. If we do, then automatically you can easily understand what is this. First what we have to do, first we have to calculate the total number of valency electrons for each atom. If it is a cation, what is the charge? How much negative charge is there? Those many electrons you have to add to the valency electrons. If it is a positive charge, and how much unit of positive charge is there, and those many units you have to subtract from the total number of electrons. That is the second point. And the third one, you have to select the central metal atom. Central not metal atom, central atom. Usually what it is, less electronegative atom is act as a central atom. and then write the skeletal structure. And after writing the skeletal structure, fourth one, you have to put one pair between the central atom and terminal atoms to represent the single bond. And the remaining electrons and the remaining unpaired electrons, remaining electron used for the multiple bond, and if it is not required multiple bond, and keep that one as a lone pairs. And remember, each and every atom should get the octet. And very important while distributing, after writing here two electrons between the central atom and terminal atoms, and the remaining electrons you have to means remaining electrons used for the completion of the octet first for the terminal atoms. Complete the octet for the first terminal atom, and after that you see the octet for the what it is known central atom. These are about what it is known here rules to write the Lewis representation of simple molecule and ions. Clear? Now we have discussed about the rules how to write the Lewis dot structure for given molecules. Clear? And we will do 2-3 examples, then we will get the clarity how to write the Lewis dot structure or Lewis representation, or we can simply say Lewis dot structures for the molecules. Clear? So first of all, which molecule they have given here? The molecule they have given is carbon monoxide, CO, carbon monoxide. Clear? So first step, what you have to do, the first step, you have to find out the total number of valency electrons. You have to calculate what it is here, number of valence electrons. So you know that carbon belongs to which group? Fourth group. Fourth group means how many valence electrons it will have? 4 electrons. Valence electrons is equal to its group number. Clear my here? So that's why in this one carbon belongs to fourth group, so it will have right here total number of valence electrons. Total number of what is here valence electrons. For carbon, how many are there here? 4. For carbon, how many are? 4. Oxygen belongs to which group? Sixth group. Sixth group means what it is here? 6. If you don't know which group, you just write the electronic configuration. Carbon, what it is now? Yeah, 1s2, 2s2, and 2p2, because you know carbon atomic number is 6. So this is valency electrons because it is the inner shell, it is the outermost shell. So how many electrons are there? 4 electrons. Oxygen means what it is? 1s. Oxygen atomic number 8, so that's why 1s2, 2s2, and 2p4. 2 plus 2, 4, 4 plus 4, 8. So how many valency electrons are present here? 4 plus 2, 6. That is one. Clear? So now, how many total number of electrons are here? Total number of electrons are here 10. Clear? So total 10 electrons we have. This is the first rule. And what is the second rule? Second rule. If negative charge is there, you have to add equal number of electrons. How much negative charge is there? But is that molecule having any charge here? Not a molecule. So that's why you need not to consider the second step here. Isn't it? So this is the and the third step. Third step means you need not write here second step and directly you can go for second step is not required. And what is the third step now? And you have to select the central atom. You know only here 2 atoms are there. You know carbon is a central atom because if more than 2 atoms are there in the molecule, then you have to select the central atom. But here linear molecule, so that's why I will write carbon actually central atom. So now under carbon and oxygen. This is clear. So this is the third one. You have written what it is here, skeletal structure. And the next what you have to do, you have to write the how many number of electrons are there? 10 electrons are there. First you have to write one pair of electrons between the 2 atoms. For the fourth rule, what you have to write now? 2 electrons between the 2 carbon atoms. Clear? Then it represents which one? Single one. Next, 2 electrons we have used. How many electrons are left here? 8 electrons are left. 8 electrons means how many pairs? 4 pairs. Now, after writing this, first what I said, and first complete the octet of terminal atom, not the central atom. Clear? This is terminal atom, this is the central atom. So that's why here I will write 1 and 2 and 3. If I write here 3 pair of electrons, then you see how many electrons are there. And here 2, 2 to 4, 4 to 6, and these 2 electrons also. Total how many electrons are there here? 8 electrons. It completes its octet or clear? Now, and we have used 6 electrons here. See totally how many electrons are we used? Previous 2 electrons. Now here 6 electrons. Totally how many electrons? 8 electrons. 2 electrons left, and those 2 electrons you write for the carbon. This is the fourth one. Now last part you have to do. In the fourth group only you have to see and whether each and every atom is getting octet or not. Check it. Clear? See in this case. And for oxygen, I will write here, simply see here. Oxygen, and here oxygen is there and 2 electrons. And these 2 electrons are belongs to both the atoms. So here carbon is having how many electrons here? 4 electrons. But oxygen is having how many electrons here? 8 electrons. It attains the octet, but not the central atom. And you have to check, and each and every atom should get the octet. So for that one, in the fourth step, we have to do something here. Here, what we have to see? Now, I have written here 2 electrons, and here how many electrons are there? 2 electrons. Clear, my friend? Now, if I put another 2 electrons here, if I put here another C, this carbon is having how many electrons here? 4 electrons. So how many electrons required to get the octet? Another 4 electrons, and these 4 electrons I will write here. You see, already 1 electron is there, and this pair I will write here, and this pair I will write here. Clear? Now I will put here oxygen. Oxygen having what it is here? 1 more pair of electrons. Now you see here what happened? And this oxygen, these electrons are belongs to both, and this is oxygen missing. How many electrons? 1, 2, 3, 4. 4 pairs means how many? 8. But this one also you see how many electrons carbon is having? Carbon is having 1, 2, 3, 4. Total how many? 1, 8. So both are attain the octet or not. So that molecule is stable. And in that way you have to write. Got my point here? So this is the final structure. Now we can write here simply how many electrons are there here? How many pairs are there here? 3 pairs. 1 pair, 1 electron pair means 2 electrons will form 1 bond. But how many electrons are there here? 6 electrons. So that's why each 2 electron we will represent it by a single bond. And now you will get here oxygen, and oxygen is having 1 lone pair of electron. And this is the final structure of Lewis dot structure of what it is by carbon monoxide. You understand or not? This is the thing you have to do. Clear? All rules we have satisfied or not? First, what we have done here, we have calculated the number of valency electrons. How many number of valence electrons? 10. And after that, we have written the skeleton structure, carbon and oxygen. While you are writing the skeletal structure, immediately you have to put the 2 electrons between the central atom and terminal atom. And after that, remaining electrons, you have to first arrange for the terminal atom, not the central atom. First try to satisfy the central atom octet, and after then, first try to attain the terminal atom octet, and after then followed by which one? Central atom. So that's why I arranged here 6 electrons. So automatically oxygen is it attains the octet, and after that I will see carbon is attained the octet or not. Then see here carbon is having only 4 electrons. So that's why carbon needs how many electrons? Another 4. And those 4 electrons I will write these 4 electrons here in the between carbon and oxygen. Then what will happen? This carbon is also having 8 electrons. Oxygen is also having 8 electrons. And this is the Lewis dot structure. So another one I will write. Draw the Lewis dot structure for NO2 minus. What it is, Maria? Write the Lewis dot structure for NO2 minus. Clear, ma? So again, same rule we have to follow. So what we have to do first of all? First of all, you have to calculate the number of total number of valence electrons. Nitrogen belongs to which group, ma? 5th group. So that's why first calculate total number of electrons. Total number of valence electrons. So nitrogen belongs to which group? fifth group, or otherwise if you write like this, you will get it. Clear? So, and you will get the 5. Oxygen, just only we have 6. How many valence electrons oxygen has? 6. 6 means, you know, 6 into, how many oxygens are there here? 2. This is total number of valence electrons. So, what it is now? 5, 5 and 6 into 2, 12. Totally how many are here? 17 electrons. This is total number of valence electrons. Clear? Second step. Now in the second step, if it is a anion, you have to add the electrons. If it is a cation, you have to subtract the electrons from the total number of valence electrons. Now it is a which one? NO2 minus NO2 minus NO2. I have already calculated valence electrons. How many? 7. It is how much negative charge is there? 1 unit negative charge, so that's why you have to add 1 electrons. Total number of electrons how many? 80. That is the second step. Because previous this molecule doesn't have any charge. Clear? So this is second step. What is the third step here? You have to select the central atom. Clear? Nitrogen and oxygen. Which one is the less electronegative? Oxygen is most electronegative and nitrogen is less electronegative. So that's why generally we will consider the less electronegative atoms as a central atom. So which one is the central atom here? Nitrogen is a central atom. Clear? Next what you have to do? Arrange this means you draw the skeletal structure. You know that nitrogen, how many oxygens are there here? 2 oxygens. One is oxygen and here another oxygen. You should not put here nitrogen is there, oxygen is there and oxygen. Why you should not write like this? Because we have the central atom. If you write like this, oxygen becomes a central atom here. Got my point? But which one should be the central atom? Nitrogen. Around that nitrogen, you have to arrange the remaining atoms. Got my point? So that is nitrogen. Clear? Now you have written. Immediately, what you have to do? You have to write. I will write very clearly. This is nitrogen and there oxygen and here oxygen. Immediately, what you have to do? You have to put the one pair of electrons between the atoms. Nitrogen and oxygen, 1 pair of electrons. Nitrogen and oxygen, 1 pair of electrons. Completed or not? Yes. Next, what you have to do? You have to do here. You see how many electrons total we have? 18. How many electrons we have used here? 4 electrons. Remaining how many electrons will be there? 14. Now arrange the remaining electrons to central atom or terminal atoms. You have to remaining electrons first arrange for the terminal atoms, not the central atom. So now, and see, 14 electrons are there. I will write 6 electrons here on the oxygen. Why? Because these 2 electrons also belongs to which one? Oxygen. So that's why if I write 6 electron, it attains the octet. Wow. Clear? So now, how many electrons we have used here? 1, 2, 3, 4, 5. Totally how many we have here? 10 we have used. How many left here? 8 left. So I will write for this one also 6 electrons. Clear? So that is, I want to say here, first of all, terminal atoms should attain the octet. You have to arrange the electrons in a such a way that first terminal atom should attain the octet. Clear? So now, both are octet here. Now how many electrons you use? 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs means how many? 16 electrons we have used. Clear? 16 means 2 electrons left here, and now the 2 electrons you put on the nitrogen. That is Lewis structure. Clear? And fourth step and last step, what we have to do? And you have to whether all the atoms attains the octet or not, you have to check it. Clear? See now. And in this case, what happened? First of all, oxygen, you see, oxygen attained the, what it is here? Octet. 1, 2, 3, 4. 4 pairs means how many electrons? 8 electrons. And this oxygen also attains the what it is octet. Because how many electrons are there? 1, 2, 3, 4. Total octet. Clear? Now central atom, you see, central atom is, remember one thing. Whenever the electrons present between the 2 atoms means those electrons belongs to both the atoms. Clear? So that's why, this is the for nitrogen central atom. Clear? Nitrogen is having how many electrons here? 1, 2, 3. 3 pair. 3 pair means how many electrons? 6 electrons. So it is not in the octet. So that's why what you have to do, take any one of these pair of electrons, put in between the oxygen and nitrogen. Then what happened? You see, oxygen I have written 1 and here 2, and in this pair of electron I will write like this. Already one pair is there. This is nitrogen, and here nitrogen. I will write this is same oxygen, and this is. See Manu, what happened? This oxygen is attained how many electrons? It is octet only. 1, 2, 3, 4 pairs. Clear? And if you see this case, already one pair of electrons is there on the nitrogen. This is. So in this case, nitrogen also attained the octet, and here oxygen also attained the what it is octet. So that's why. What is the structure here? And you know, and we have to forget to write here. There is a minus charge is there. You have to write in this. So when ions are there, I already mentioned, we have to write those Lewis dot structure in a square brackets. Here, no? Negative charge. So now what I can write here, you see, nitrogen. Here, one pair and one pair. Two pair of electrons are there means what is no? One pair means one bond. Two pairs means two bonds. And here, there is one electron here, lone pair of electrons here, and another. Now in this case also, and the two electrons are there, one bond, and remaining you write here. This is what it is my Lewis dot structure of NO2 minus. Next one, another one example we will discuss. You understand what we are, how we are writing the Lewis dot structure for given molecule? Yes, just we will write one or two examples, then we will get the total clarity. Clear? See now, draw the Lewis dot structure of CO3 2 minus. CO3 2 minus. Clear? So what first you have to do? First step, you have to calculate the number of valence electrons for each atom in the molecule. Clear? So now you know first one, total number of valence electrons of each atom. Clear? So carbon belongs to, I already mentioned, 4th group. So that's why how many valence electrons you have, right? 4 valence electrons. And oxygen I have already mentioned 6, but how many oxygens are there? 3. So this is 4 plus 6 into 3, 18. So you will get what it is, 22 electrons. Total how many electrons are here? There are total 22 electrons. Now total number of electrons to be distributed means second step what you have to do. This is valence electrons, but total number of electrons to be distributed. Total number of electrons to be distributed means what you have to do now? Means you have to write the total number of electrons of the CO3 2 minus. Now valence electrons how many are there? Carbon and oxygen will have the, total how many valence electrons? 22. But here what is the charge? 2 minus. 2 minus is there. It is a nodal molecule or charge molecule? Charge molecule. What is the charge here? 2 minus. 2 minus means what you have to do? You have to add the 2 electrons. So this is total electrons distributed for the Lewis dot structure. So how many are here? 24. This is the second step. Clear? Next one. Third step. What is the third step? You have to just identify the central atom. What is the central atom here? Carbon and oxygen. Which one is more electronegative here? Oxygen is more electronegative, so that's why it never acts as a central atom. In this case, clear? So that's why. And which one is the less electronegative atom here? Carbon. So carbon is the central atom. So that's why first right there carbon is the central. And around this central atom you have to arrange the remaining atoms. What are the remaining atoms here? Oxygen. Terminal atoms. So right here oxygen, oxygen, and oxygen. Clear? So while you are writing, charge is there. So you have, this is actually terminal. Now, first of all, what you have to write? You have to put the each between these atoms. This is skeletal structure. Clear? I will write above. If you want, I will write here only directly, no problem. You can write there only. So carbon, this is carbon, oxygen, oxygen, oxygen. This is the skeletal structure. What is the fourth rule here? Here only I will include the fourth rule. Clear? First of all, you have to write the two electrons between the central atom and terminal atom. Here also how many electrons you have to put? 2 electrons, and here also you have to put the 2 electrons. 6 electrons I have used. Clear? Now, first of all, first try to complete the octet for the terminal atoms. Clear? Now I will write 1, 2, 3. This oxygen attain the octet. Clear? Now 1, 2, 3. This oxygen also attain the what is octet. Now see how many electrons we have used. Just calculate the pair. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pair means how many electrons we have used here? 18 electrons we have used. Remaining how many are there here? 6 electrons are there. Means 3 pairs are left here. Clear? Means those 6 electrons I will write for the oxygen. This oxygen also attain the what it is octet. Now you have to write this one in a square bracket. Why? Because it is a which one? Ion. Ion means you have to write in the square bracket the Lewis structure. Okay? Now see, oxygen. This oxygen attain, all 3 oxygens attains the octet. Octet means what? 8 electrons are there with the each oxygen. But see now, lastly you see the central atom whether it is attain octet or not. See now, central atom. This is the central atom. Central atom is having how many electrons here? 6 electrons. So, and 2 electrons are less to attain the octet. So that's why what you have to do here, any one of these electrons from any oxygen, you can bring 1 electrons between the oxygen and carbon. Then carbon will attain the octet. Suppose I will write this. Then what will happen is and this oxygen is having. So I will write 3 pairs are there. 1 pair I will write here. Already 1 pair is there. That is, and remaining you have to write in the same oxygen, and here also oxygen, and here electrons. Clear? Now you see here this carbon is already having see now in this one what will happen? Carbon, you see, carbon attain what it is octet. 1, 2, 3, 4, 8 electrons. This oxygen also you see 1, 2, 3, 4. These electrons also belongs to which one? Oxygen. So that's why both carbon and oxygen also attains the octet. So this is the now what it is not here Lewis structure. And simply you can write this is with 1, 2 electrons means how many bonds? 1 bond. So here I will put 1 electron. This is 1 bond, and here also there is a 1 bond. And here how many bonds are there? 2 pair of electrons are there. There are 2 bonds. And now you write here for this oxygen, and 3 lone pairs are there. And for this oxygen also there are 3 lone pairs. For this oxygen there is a 2 lone pair, and carbon is attained the what it is octet. Now all atoms attain in this molecule octet. So this is the correct structure, Lewis dot structure for which one? So this is about the what it is here Lewis dot structure. So I will write here one last example boson, and after that I will give you one table, clear, and I will write some examples, and you will just check it whether what I will write here are correct or not once you check it. Clear? So next one is draw the Lewis dot structure of ozone. Ozone symbol what it is here? What is the chemical formula of ozone? O3. Oxygen means O2. O3 means it is a ozone. So first of all, this is ozone. What do you have to write? Write that is this molecule is a neutral or charged? Neutral only. So second step you need not to write here. Clear? So how many total number of valence electrons here? Total number of valence electrons. How many? Oxygen 6. 6 into 3 total how much? 18. Clear up? Now, so what is the central atom here? All atoms are same, so that's why oxygen only act as a here central atom. Here you see previous 2 different atoms are there. So carbon is less electronegative than oxygen. So carbon is act as a here central atom. But here what it is now? All atoms, 3 atoms are same. So one of the oxygen is act as a central atom. And around this you put the oxygen atoms. This is the skeletal structure. This is oxygen. This is the central atom. and 2 this, and this is LH. Now immediately what you have to do? You have to put here and 2 electrons between the central atom and terminal atom. That 2 electrons represents what is a single bond. One bond means 2 electrons. If 2 electrons are there means 1 bond. Clear, man? Now arrange the remaining electrons. Clear, man? What you have to do first of all? The remaining electrons we have to arrange for the central atom or terminal atoms. For terminal atoms, not for the central atom first. Clear? Now, and here oxygen. This oxygen is having already 1 pair of electrons. 2 electrons are there. To attain the octet, how many electrons required? 6 electrons. So that's why I will write here 3 pair of electrons like this. So this oxygen attained the octet, and this oxygen you see, and I will write for this oxygen also 3 pairs. Then and here 1 pair is there. This pair belongs to this oxygen and also for that oxygen. Clear? So this oxygen also attained what it is? 1, 2, 3, 4 octet. Now you see how many electrons we have used? 1, 2, 3, 4. 1, 2, 3, 4. Total 8. 8 into 2 means how many electrons we have used here? 16 electrons. How many electrons left here? 2 electrons left, and that last remaining 2 electrons you put as a pair for the central atom. That is the structure. Clear? Now, if you see this one, and this oxygen attained octet, and this is also octet, but this oxygen you see, how many electrons are there here? Central oxygen. Central oxygen 1, 2, 3, 6 electrons are there. 2 electrons are less to attain the octet. So that's why any one of the pair I will write in the middle. Then this central oxygen attain the octet, and also this oxygen attain the octet. Any one of the oxygen, that is your patient. So here oxygen is there, and you will get, suppose if I write for this oxygen, already there are 2 electrons. One of this pair I will write in the middle. So now here 2 electrons. Previous 6 electrons, now 4 electrons. And this electron also belongs to this oxygen. So now here oxygen, and there is an electron, and here and here. Now see what? All are having octet. And previous already this oxygen is having here. So this oxygen now octet, and this oxygen also octet, and this oxygen also attain octet. Here all are now attain octet. So that's why write the structure here. And 2 pair of electrons are there. There are 2 double bonds. Clear? 2 bonds here, and here there is a 1 bond. But while we are writing this, we have to write electron pairs. This is oxygen 2 electron pairs. This oxygen will have 3 pair electron pairs, and this oxygen have 1 pair of electron. But we have to write one positive charge here and on this negative charge. This charge we will call as a formal charge. And how we have written for this positive, for this oxygen positive and this negative, that we will discuss in the next class we will discuss. So here I have written molecules are ions and the Lewis structure, and this is one and this is the different. Clear? So molecules and the Lewis representation. Clear? So I have already explained how to write the Lewis representation. Here with the bonds I have mentioned, at last we have used it to write, right? I explained previous, and at last that bond electrons between the central atom and terminal atom, if 2 electrons are there, we use it to write, we use it to represent the 2 electrons with a single bond. Clear? So that is here. So, and I have mentioned some examples in this one. NO2 minus we have discussed, and O3 minus we have discussed, and CO we have discussed, and the remaining also you have to practice in the same way whether you are getting this type of structure or not once you check it. Clear? So these are some examples most of the time, and here I have written CO, SO2, O2, H2O2. In this case you see H2O2 is there. Okay, I will explain. See in this one H2O2, hydrogen is present here. What it is here? Hydrogen. This is actually one oxygen. To one oxygen there will be one OH should be attached, and another hydrogen should be attached. Here you see, this is one bond means how many electrons here? 2 electrons. One bond means how many electrons? 2 electrons. So you may ask here, and this is one bond means how many electrons here, 2 electrons, and here also what it is now, 2 electrons. Means this oxygen attained the octet. Clear? But hydrogen, you see, hydrogen is attained the doublet. Doublet also, you know, octet or doublet, those are stable structure. For the hydrogen, like lithium and beryllium, and they attain the doublet, not the octet. Clear? So that's why in this case, and here also one hydrogen is there here. This hydrogen also attains the what it is one doublet. Clear? If I write here HNO2, see what it is here. What is the central atom present in the in this HNO2? You know, least electronegative atom is hydrogen, but hydrogen cannot act as a central atom because being a small size, it cannot hold the many, you know, terminal atoms. So that's why nitrogen should be the central atom. Clear? And after that, oxygen is there, and here. If I put oxygen, there will be like, you see, oxygen, and here oxygen. You may ask here, hydrogen should be attached in this case. Clear? So 3 groups are there, and we should not arrange in this way. Nitrogen, oxygen, and oxygen is there, and Y means, you see, and this is hydrogen. Hydrogen always attached to the highly electronegative atom. That is what it is not here, oxygen. Clear? And suppose if I write in this case, you have to calculate the number of the electrons here, valence electrons, and then just arrange these electrons. Clear? So this is about what it is here, Lewis representation for the molecules and also what it is ions. So next one is formal charge. Clear? So actually, while we are writing in the molecule, the charge, there is no charge on the individual atoms, and the total, what is the charge is there, the total charge, it is not belongs to the individual, it is a charge as a whole the molecule. But sometimes it is necessary and we have to write the formal charge. Formal charge means the charge on the each and every atom in the molecule. Clear, my friends? But and that total, if I write here CO3 2 minus, I mentioned CO3 2 minus means I have not written here CO and here one oxygen minus charge and another oxygen minus charge. There is no charge on the other oxygen. We will not write here. This charge 2 minus is not to the individual of any atoms in the molecule. This charge is as a whole. This charge is belongs to total whole the molecule. Clear? But sometimes you should write the formal charges, means the charge on the each and every atom. So that is how to calculate this formal charge. Very important question for the PU as well as counted. Clear? So previous I have written, have you remembered or not? Oxygen is ozone I have written. When I have written ozone, I have written like this. Negative charge is there. Positive charge and negative charge. And this is the charge. The charge present on the individual atoms we will call it as a formal charge. And how to calculate this formal charge? We have one formula to calculate the formal charge. Clear? So what is the formal charge here? Formula. The formal charge is equal to here, and total number of valence electrons, in free atom. Clear? This is total number of the valence electrons in free atom minus. Clear? Total number of lone pair electrons. Lone pair are, non-bonded electrons. Non-bonding electrons. Clear? This is minus half into total number of bonding pair electrons. This is the formula. Clear? No? So what is the formula here? Formal charge is equal to total number of valence electrons in a free atom. Simply I will write here Na. Na means what it is now here? Total number of electrons of a free valence electrons of a free atom minus and total number of lone pair electrons are non-bonding electrons. Total number of what it is now? Lone pair electrons minus 1 by 2 into number of bond pair electrons. This is what we will call here formal charge. This is the formula for it is here formal charge. And very important this formula. And to write the formal charge, first you have to write the Lewis dot structure of the atom. Clear? No? We cannot directly, by seeing the molecule, we cannot directly write the what is not here formal charge. So what you have to do? First of all, you have to write the Lewis dot structure of the molecule, and then you have to calculate the formal charge. Clear? Suppose I will write here example. I will write ozone. Ozone we have taken previously. Ozone means you know already what is the structure of ozone. This is clear. So here there are 2 electrons, and here there are 3 lone pair of electrons, and here this is the Lewis dot structure of the what it is here ozone. Here I will represent this is 1, this is 2, and this is 3. Clear? Oxygen atom 1, oxygen atom 2, and oxygen atom 3. Now you have to calculate the individual charges of each and every atom in the ozone. Clear? So first one I will calculate here. First you have to write the Lewis dot structure. We previously have written, so that's why I have written directly here. Clear? So first oxygen. For first one formal charge. For first oxygen. How to calculate the formal charge? Clear? Formal charge. Formal charge is equal to what is the formula here? Total number of valence electrons in free oxygen. This is oxygen. This is what is oxygen. Oxygen means you know what is the valence electrons. Oxygen belongs to cis group, so that's why valence electrons how many? 6 valence electrons. That is total number of valence electrons of the atom. I am talking about oxygen. I am calculating the formal charge of the oxygen, so that's why I have taken valence electrons of the oxygen. Clear? Next minus number of lone pairs. Lone pairs means lone pair of electrons. Number of what it is here? Lone pair are non-bonded electrons. This we will consider as a lone pair of electrons. What are dots are there on the atom after writing the bonds between the atoms? Now what are there on the atom? These electrons we will consider as a lone pair. How many lone pairs are there here? 2. And here how many lone pairs this oxygen has? 3 lone pairs. And this oxygen has 1 lone pair. These are not participated in the bond formation, right? So that's why it can also be called as a non-bonding electrons. Clear? So for this oxygen, how many non-bonding electrons are there? 1 and 2. Got how many? 1, 2, 3, 4. That is, you have to write the 4 minus of bond pair electrons, bonding electrons. Here, electrons which are formed for the bond, that we will call as a bond pair electrons. Here, how many bonds are there? 2 bonds are there. 1 bond formed by how many electrons? 2 electrons. Here, how many bonds are there? 2 bonds. So that's why how many electrons are there? 4 electrons. 2 bonds means how many electrons are involved? 4 electrons. So if you do this, 6 minus 4 and here minus 2. So 6 minus 6 is equal to 0. What is the formal charge on this oxygen? 0. 0 means you need not to represent. Clear? Next one. Second oxygen. For the second oxygen, calculate the formal charge. Calculate the formal charge. Clear? Calculate here. This is oxygen. Clear? Now I am calculating the formal charge for this oxygen. So what is the valence electrons for oxygen here? 6 minus total number of lone pair or non-bonding electrons. This is lone pair of electrons. Are non-bonding, not participating in the bonding. So that's why how many electrons are there? 2 minus 1 by 2. Bond pair electrons are there. This oxygen forming how many bonds? Here 2 bonds. Here 1 bond. Total how many? 3 bonds. 3 bonds means how many bond pair electrons? 6. 1 bond forms 2 electrons. Means 2 electrons form 1 bond. So that's why. And here you will get 6 minus 2 and minus 3. So you will get here plus 1. So what is the formal charge on this oxygen? Plus 1. So last one. Third one you calculate for the third oxygen. Formal charge you calculate. Calculate the formal charge for the oxygen. So what is this oxygen formal charge you calculate? 6, because first of all we have to write lone pair of valence electrons, and after then you know lone pair of electrons. How many lone pair of electrons? 1, 2, 3, 4, 5, 6. So total how many? 6 minus bond pair electrons of bond pair. Bond pair, how many bonds it is forming? This oxygen is forming only one bond. So that's why one bond means 2 electrons. So that's why 6 minus 6 minus 1, 6 minus 7 is equal to minus 1. So for this oxygen, one negative charge is there. That is plus 1 or minus. Here minus 1. 1 you need not. So this is about the how to calculate the formal charge in the molecule for each atom. So here they have given one question. Calculate the formal charge on carbon in CO3 2 minus ion. So you know I have already written CO3 2 minus ion Lewis dot structure, so that I will write here directly the structure. Clear? So, and you know this is the carbon, oxygen and oxygen, and here 3 lone pair of electrons, and this oxygen will have 2 lone pair of electrons. This is minus 2. You have already written. Clear? So now in this case you have to calculate the formal charge for carbon. They are asking formal charge of which one? Carbon. Clear? So how to calculate? Carbon, first of all you have to write the valence electron. Carbon belongs to which group? 4th group, so that's why 4 valence electrons. This is formula. Number of valence electrons of atom, free atom, carbon, minus lone pair of electron. Is this carbon having any lone pair on this carbon? No, there is no lone pair. Means like this. There is no lone pair. 0 minus half into bond pair electrons. This carbon is forming how many bonds? 1, 2, 3, 4. 4 means how many electrons? 8 electrons. Clear? So that's why 4 minus 2 into 4 and 0. So that's why what we will get now? 0. The formal charge on the carbon is what it is here? 0. And now I am giving here homework to calculate the formal charges on the oxygen also. 1, 2, 3, and calculate the formal charge on the oxygen. And next they have given here formal charge on Cl in ClO4 minus. Cl in what it is here? Cl4 minus. So they have given here formula. First you have to write which one? You have to write the Lewis dot structure, and for the Lewis dot structure to write, first of all directly I will give and you write, you just practice. And this is chlorine, and here oxygen, 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 oxygen. This is minus. Clear? This is minus 1. So now you know these are lone pair of electrons on each oxygen. Clear? So here lone pair of electrons on each oxygen. Clear? So now what they are asking? They are asking to calculate the formal charge on the chlorine in this molecule. Clear? So what is the formal charge? How to calculate formal charge here? To calculate the formal charge, first of all you have to write the valence of electrons. We have chlorine. Chlorine belongs to which one? 7th group. 7th group means you have to write the 7 electrons minus, and the lone pair of electrons. Is there any chlorine having any lone pair? No. 0. Of how many bond pairs? 1, 2, 3, 4. 4 means it is having 8 electrons. So that's why 7 minus 4, you will get what it is here, and you will get the 3 is the formal charge on the what it is here. So here this is the formal charge on the central atom, and you also calculate and formal charge of each terminal oxygens in this compound. And also I have given here homework for you. Calculate the formal charge on the central atom and as also terminal atoms of this following compounds. So first of all write the Lewis dot structure, and after that calculate the formal charge for the central atom and also for the all terminal atoms. And this is homework.